It's going to be a short video describing ionic radius. So just like in the last video about atomic radius, what we want to keep in mind when we're looking at ionic radius, as with all of our periodic trends, is what is the highest n level, as well as the z effective, the effective nuclear charge. So what I have here is I have two atoms, or two ions, that are isoelectronic. Iso, as we discussed in an earlier video, means the same, and electronic means electron. So isoelectronic means two ions possessing the same number of electrons. Two ions with same number of E minus. So why do these two have the same number of electrons? Well, sodium has an atomic number of 11, so it has 11 protons. Well, if it has a positive charge, it must have one less electron than protons. So that's why sodium has 10 electrons, sodium plus. Fluoride, F minus, well, fluorine normally has 9 protons. If a negative charge means it has one more electron than proton. So for that reason, the fluoride ion also has 10 electrons. Well, if they have 10 electrons, these are both going to have identical electron configurations. 1s2, 2s2, 2p6 for both of them. 1s2, 2s2, and 2p6. So what we can see is that in the n equals 1 energy level, both of these are just going to possess 2 electrons. And in the n equals 2 energy level, both of these are going to have 8 electrons. 1, 2, 3, 4, 5, 6, 7. Okay, one more. And 1, 2, 3, 4, 5, 6, 7. So these both have 8 valence electrons. So what's going to count for the difference? Well, it's not the highest n level. We can see that both of these have the highest n level of 2 in both cases. So that's not going to be it. So it's actually going to be the z effective. How much of a charge do these outer electrons feel? Well, looking at sodium, we can see that it just has 2 inner electrons. Fluorine also has 2 inner electrons. Well, what's different are the number of protons. So the z effective for sodium would be 11 minus 2, or plus 9. Whereas the z effective for fluorine is 9 minus 2, or plus 7. So that plus 7 and that plus 9, the plus 9 is much larger z effective. That's again going to contract that valence shell inward and cause Na plus, or the sodium ion, to be smaller than F minus, the fluoride ion. And this is really the way that you want to look at it. Other things to take in mind, well, you know, F minus has a negative charge. There's greater electron-electron repulsions because that negative charge isn't canceled out by the positive charge. So that's another reason that it's larger. In fact, F minus is drastically larger. It's about twice the size of the sodium ion. And that's pretty much it. You know, that's the best way to understand ionic radius. As we continue to go through the next videos, I want you to try to guess. Thinking about the highest n level as well as the z effective. Before watching the next videos, please take a guess as to why, because if you keep these two things in mind, the principal energy level and the z effective, you're pretty much able to discern everything within the periodicity trends.